abbiamo un'altra. Sì, sempre. No, sempre per l'accoppiamento automatico. Adesso è cost benefit.
Good morning, everybody.
Good morning.
Good morning.
Good morning.
Good morning.
Morning.
Good morning.
Jens, you have to unmute your microphone.
Perfect, thank you. Yeah, we wait until everybody is seated in the big, nice seats with popcorn and Coke for starting the CBA movie. Maybe we allow further 30 seconds because there are still people joining. It's again a long list of participants. Very good, very good, very good. I think we produce blockbusters, huh, dear colleagues? We have always a huge attendance. And yeah, 1 minute past, we are still having people entering the room, which is totally normal. But as we are absolutely tight in time for the huge amount of information, we will start. And we from the team say hello and good morning to you all. And we are so grateful that you are here in the Duckcelerate workshop on cost benefit for the digital automatic coupler. It's very good that you take the time, that we have the possibility to explain you a little bit more in detail from the authors, from the creators of the stuff of the CBA cost benefit analysis, what this is all about. And first of all, a very short introduction to this team. I start with the ladies. Ivana Todt. Ivana, maybe you can wave your hand and say, this is Ivana from ÖBB. She has organized all that around. So without her, we wouldn't be here. Thanks very much for doing that. Peter is exactly on my screen right to her. Peter Perstel from Virtual Vehicle Austria. He is the project coordinator for Duckcelerate. Also, a big thank to him. This is a lot of work. And this seminar here, this webinar takes place within the dissemination activities of the Duckcelerate project. And it's stuffed with also members from the EDTP. In an unpolite way, I will do it. I will start with myself. I'm Jens Engelmann. Yeah, maybe even we can go to the first slide because then we see, I think this is it the first slide with my name on? I think so. And my name is Jens Engelmann. I'm program manager. Yeah, this is very good. Thank you. The program manager of the European Duck Delivery Program, Duck like Digital Automatic Coupler. And we have here with us today Michel van Banen. Michel, maybe you can wave your hand. This is Michel. He's from the European Union Agency for Railways, or shortly known as ERA, and he's the lead of the work package 5 about CBA, cost, benefit, and funding, financing, all that stuff. And he is supported by Nicolas Goel. This is the one sitting in this nice city here with the river and the church behind him. And he's from EY. Formerly EY, now he's Blue Arch's partner, and has supported us from the very beginning of the whole story down to 2020-21. And the most of the work that you see here, except the part of the contributions given, has been done by these two colleagues here. And so they are the absolute experts to let us know. What will we do today? A short introduction on why DAC and what is a CBA and why have we done that. What you will see is mainly the slides and some stuff that we used for the DAC user consultation, and we take it as a good opportunity to explain that, to re-explain that to you. Then Michel will take over and explain you what a CBA is about, how the methodology for this all was done, and what the main results are. And then Nicolas enters into the explanation of what is the baseline of the of these scenarios and the different costs, the cost options on CapEx and OpEx. Michelle will then retake over and talk about the nicer part, which is the benefits. And then we will have the audience Q&A. We planned that for 11:40 until shortly before the end. And we have rearranged it in a way that we take all the audience until the, or all the questions until the end, because if not, we would not have enough time for the explanation. If you have questions, you can write them, but Peter will explain you in a second how to ask the questions that we can use later. Yeah, and that means this is the agenda. This is what we will do today. The questions in between, we have decided not to do them. And Peter, here with this, I would ask you, can you please explain us the technicalities and how this is all going in with the exchange between participants and presenters today and how we use the inputs from the audience? That would be nice. Thank you.
Thank you, Jens. Yeah, very quickly. We have two possibilities to ask questions. First is Slido. I would, from a technical point of view, advise you to use Slido. You have the link. You just need to put in www.slido.com and use this number and write the questions in the cost benefits analysis Slido we opened. The other possibility you have is to use the MS Teams chat. This is the other function we have. So I'm gonna sort of manage both systems and get the questions at the end. I just saw there, because by the workshop 2 days ago, this number isn't actually correct. I'll pop the right number in the chat in a second. Yeah, that's from the workshop we had 2 days ago. I'm gonna put the correct number in the chat just in a few seconds. Just be aware this meeting is going to be recorded. So if you need to distribute it in your company or listen to this recording afterwards to take further notes, please do so. And yeah, I wish you a very informative meeting, and I'll take care of all the questions and we're gonna have them answered at the end of this meeting.
This is absolutely perfect. Thank you, Peter. And I can already anticipate also the final and ultimate aim of this workshop is that we certainly encourage you to participate and to contribute even further to that. And to the way how you can do this will be shown at the end, because the main thing now of these webinars, and especially of this subject here, is that we have invented something, but we cannot be sure that we have met all preconditions and all boundary conditions to 150% correctness, and this is why we ask, but I will let you know later. Yeah, and with this, Peter, I think next slide, very quick, the scope of this European Duck Delivery Program and who is represented. You know, here you see the different organizations, companies in the different countries of Europe who are represented in this Duck Delivery Program. Many of you are part of these numbers here of the green fields, and this is also the scope that we wanted to cover with our CBA, and especially also the ones which are not yet represented here, that we also get their input, but at least to show you that for the things that we calculated and we found out, we have a quite good basis of representation, so we are not fully somewhere in the theoretical clouds, we are in reality, and we want to be even better in the reality by exchange with you. So this is more or less where we are located overall. Not bad, I would say, for such a sector initiative. And if you go to the next slide, we have then, this is a smaller subset of the agenda. And I will continue with the introduction on the next page. Exactly. So also very shortly, because I think most of you know that all, I will not read out these slides, but why do we want to have a duck and what's the problem to be solved? I mean, this is also each time, Michelle will explain the methodology, that you have to explain why you want to do something. And that means normally the answer should have some benefits. And you see that here the main challenges in rail, besides spring, summer, autumn, and winter, these are productivity, quality, and especially capacity in rail freight in Europe, and seen in comparison with the objectives of the Green Deal and the overall aim to achieve a higher market share and modal split, we have to do something. And on top, we will have even less and less people out in the field working there, even if we think that manual work is nice and could bring us all the efficiency benefits because we just have to work quicker and harder, then we will, due to the retirement waves, have even nobody else left after 2030 to 35, 2040. This is why rail needs to think, and especially rail freight needs to think about automation. And this is when now this idea of digital automatic coupling comes in. Okay. Next slide, please. What is this solution? I think also nothing new. You have the couplers in between locomotives and wagons, and you not only have the mechanical and pneumatical coupling function, but you have especially, that is the D, you have these green boxes on the freight wagons, on the freight cars, on the locomotives, with whom you can do a lot of good things, which exactly shall create the benefits we are talking about. And they are represented in the use cases which come on the next pages, but you will see that the freight wagon turns from something very metal and steel and unintelligent to something more intelligent, and this is the added value and at the same time also the complication. Now, this is the EDTP itself. You have seen the map. It's okay. And the what is important to know for you, that the technology work for developing to the end and to a serial product status nearly and for ready for authorization, this what the work is done in what is set in the middle in the flagship project 5 within Europe's rail. I mean, also we as the European, as the EDTP, we are located within Europe's rail, which is the successor of Shift to Rail, yeah, the joint undertaking in Brussels. But the technology work itself is still a little bit of research and innovation. And here we have a huge 100 million project, which is called Full Digital Freight Train Operations, as part of a bigger project, Transform Rail. And here they will, until end 2025, develop most of these gimmicks that we were just presenting, the digital, the mechanical, and so on. So we expect something to deploy ready for realizing the use cases by 2025 and beginning 26. And the EDTP itself, the people you are talking to here, we in the meantime will prepare with most of you, all of you, as many as possible of you, the preparation, the foundation for the deployment, which is migration planning, and also especially the CBA, because on the next page, you can see that I will skip maybe the how that would be implemented, because that will be repeated by Nicolas shortly in the migration strategy, and we had a special seminar on it. But the thing here, why the CBA and why a sector consultation, is that one of these things that we can do and we must do before any deployment is done, and we ask someone for money, is that we prove that it's a good thing to do. And this is exactly why we need to compare costs and benefits. And then this sector consultation, with which we invite you all to contribute to it, is the possibility for us, the chance, the opportunity to get the right data in, so that afterwards no one can say anymore that this was all wrongly assessed and just nonsense. And we think we are on a good way with this here. Okay, and the CBA, exactly how that works, you will learn from Michelle. Okay, next page is then the use cases. I said use cases. What are use cases? Use cases are these functionalities which are enabled, which are made possible by the technology. And you see here the different areas in this core system, which is also mainly in shunting and preparation. You have the functions of automatic coupling. That's easy. It's just cluck, but also the manual uncoupling, but also the remote and automatic uncoupling, which is then the DAC 5 level. I will not go into details of technology, but maybe just very shortly. So everything below 4 is still mechanical. 4 is a coupler with automatic coupling, of course, and manual uncoupling, but has already the digital components and the electrical connector. And the DAC 5, if this is not yet known, is the full automation level with either uncoupling from the loco or from a remote tower or from somewhere. Yeah, and then you have all these additional gadgets like the parking brake, like maybe rear view cameras on the right side, but these are maybe a little bit more, they are not the core applications, yeah. But what we strive for, where we really get time savings, this is in the train preparation. You see in the middle, automatic brake tests, calculation of the brake capacity, and all the basics for a later automated technical wagon inspection, which we cannot be fully provided by the DAC system, but at least the basics for that. And then also for the train run, you will see train integrity. That means we could solve the chicken egg problem with ETCS level 3, that no one knows where the end of a freight train is, and stuff like that. And there are more further other digital use cases, the conditions of the loads of the cargo, the basics, which is sometimes very helpful can be very helpful for the wagon keepers, if they are private or if they are within a railway undertaking, that they can start to better analyze the data on the wagon maintenance, preventive, predictive maintenance, maybe even, and some more, all that you can do when you have energy and communication on the wagons. Okay, so and how this deploys into a nice world of costs and benefits, you will learn. The question is, Michelle, should I spoil now everything with this management summary, or shall I leave that to you? Because if I read that out, you will have, okay, maybe shortly.
Then I don't have anything to tell anymore. No.
Exactly. So, but maybe the important two numbers here that you have maybe quickly seen on the page before is that we are talking about the total scope of 450, 460, maybe 430, something around this 1,000 freight wagons in Europe to be equipped and to run with this in the different segments: block train, intermodal, single wagon. And something around 17,000 locomotives, mainline, shunters, and so on. And then, of course, the stuff, the IT and everything that is touched, and the infrastructures. Yeah, and with this is the introduction. If you have any questions, chat them, Slido them. But with this, I would hand over in time to Michelle, because now we can really learn something about methodology and how this is all about. Thank you very much, and I hand over.
Thank you, Jens, for this introduction. So what I will do here is to give you some background on the methodology and the main results of the CBA so far. And there are indeed quite a few slides in this deck, and we did this so that also afterwards, if you want to distribute internally within your companies, it's also easier to follow. But it does mean that for some slides I will go quickly through them. If you have any points or any remarks on them, please, as Jens was indicating, use Slido, use the chat, and we can also touch upon that later on. For the CBA itself, like the foundations, I find it important to mention that within the Commission and also within the European Union Agency for Railways, we conduct impact assessments on large projects. It's also a prerequisite, and the purpose is to have a better understanding of the impact of a change. And in this case, we want to see what the impact will be of introducing DAC in the railway system compared to a situation where there will be no DAC, so continued screw coupling operations. Now, on the next slide, you will see the differences that we consider, the scope of the CBA. So we have a baseline scenario in which we have the basic principles of the sustainable and smart mobility strategy. So there will be investments in the TEN-T network and a few other improvements to the railway system. But in the baseline scenario, we consider that there will be no DAC, there will be continued screw coupling operations. And we compare that baseline scenario with several project scenarios in which we have DAC introduced. And we do not look only at DAC, we also look at several different implementations. So DAC with a number of components, and we will see in a bit like how we distinguish these project scenarios. In terms of timing, it's a large-scale investment program, and in this we follow the CBA guidelines to focus on a 30-year period. So we assess the period from introduction to impacts over a 30-year time span, which ranges then from 2026 to 2055. In terms of geographical scope, we look at all the EU countries and Switzerland, Norway, and United Kingdom as well. It has to be said that for the 1520 and 1524 system, they are not included at this point. So only for the changes for the standard gauge. In terms of technical packages, as I say, we compare different project scenarios, and in fact, we have 4 defined. And just to make this clear, this is not set in stone. We use this mostly like for analytical and exploring purposes. But we said that we want to see the impacts of DUC in several different compositions. So on the first tech package, you see that you have DUC4 with communication backbone, train integrity, automated air valve, but no DUC5. That is only being added in this tech package 2. DUC5 meaning that you also have automated uncoupling. In the tech package 3, you have the automated brake test being added, and in tech package 4, we also have the technical wagon inspection. Now, these packages, they are being used here purely like from an economical sense. Also, the technical feasibility of the different components needs to be analyzed. So I just want to say that this is not set in stone, but it does help us to have a better understanding of the relative benefits and costs of each tech package. Now, on the next slide, we see a bit like why we went ahead with this CBA, and there are a few essential elements that we consider. So first of all, we want to look at DUC not in isolation. We need to consider how the transport sector evolves, how the overall European economy evolves, and for that we gather quite a considerable amount of transport data and economic data. Besides that, we look at the direct costs. So we look at the material costs of the coupler itself and of components, but we also look at the operational implications and operational costs for railway undertakings, but also for infrastructure managers and several other stakeholder groups. Besides that, we look at the direct benefits, so the benefits that also directly fall on the railway sector, and we also look on the indirect benefits, such as the reduction of externalities, which have large social value, but not necessarily so for the railway sector in itself. As I was saying, like we collect a considerable amount of data. It's also a prerequisite when you work on an exercise with this scale. We aim to have as much detailed information as possible on each European country level. For that, we built on several national and European statistical databases, but the information is also very specific in many cases. So that is why we collaborate within the European DUC delivery program. We bring together many experts to say in this work package 5 that focuses on the economic analysis of DUC, we are with over 30 say active participants that scrutinize the results and that provide data. And besides that, we also actively engage with railway stakeholders to collect more data. And we also hope that we can collect more feedback also through you to improve this CBA. Now, how does it look like? How does the CBA model look like? On the next slide, you'll see a bit how these different inputs feed into this CBA calculator. And this WP, that stands for work package, that shows a bit the relationship that we have with the other work that's being done within this delivery program. So what we want to highlight here is that this CBA is not being done in isolation. We very much cooperate and we build upon the findings of the different work packages. And this information, and that's a challenging task to bring together in one model and to have these outcomes so that we understand whether it's a good idea to invest in DUC, yes or no. Now, on the next slide, I try to highlight the basic logic in this CBA calculator itself. And some of you already might have seen the model because we also distribute this. Everybody can access it, everybody can have a look at it. But admittedly, it's also quite complex because of the many use cases, the many countries, and the large amount of detail that's being brought together. So what I try to do with this slide is to highlight a bit the basic logic of what is actually happening within this model. So in essence, you go from several kinds of inputs that we then look into, some inputs in terms of financial resources, material, and some changes that we assume, both on operational level and legal level, leading to outputs. So those are the faster operations at sites, like terminals, like yards, like sidings, the digitalization of freight trains, and the enablement of heavier and longer trains. And in total, these 3 points, they are being captured by about the 26 use cases, the 26 specific benefits that have been defined by the DAC delivery program. Now, having that on freight trains leads in turn to some outcomes, to system optimizations, greater capacity, higher utilization, and a modal shift, which in turn will lead to greener and more digital rail system, in which rail should take a larger role in the overall European transport system. So this slide tries to capture like the basic logic and the basic idea behind the DAC implementation. So that's a bit for the methodological background of where we're coming from, but like every study, there are also quite some limitations and interpretations that need to be understood before working with the model and working with results. Each study has its limitations, and more so for a study with the complexity that we're dealing with. So on the next slide, you see the main points that I want to emphasize here. So the results that I present today, and that you also will find in the CBA model, and you also might have seen in the CBA user consultation, it captures the findings of the EDDP till the end of September. And by so, it is not a completed CBA. There's lots of ongoing discussions on the coupler itself, on the technical capabilities, on the costs, and also on the benefits and use cases that it enables. So by default, this cannot be a completed CBA. So we will not say that this will be the final results, which I find important to emphasize already at this point. Secondly, like data quality can be improved. We collect information from all different countries, and it's challenging to have data quality on the same level for each and every variable and for each and every country. So we're making steps in this, but we also really depend upon the collaboration, on the input, on the support of the entire sector to help us get a better understanding and to really see what the impacts of DAC would be for each specific group of railway stakeholders and each specific country. And we really for that depend upon strong collaborations. What's also important is that the CBA assumes a baseline scenario that is aligned with this European ambition to double rail freight by 2050. This does not only imply an investment in DAC, it also implies a large investment in infrastructure. So we assume in our model for the time being that this doubling of rail freight can be achieved with DAC. But it does mean that we have very many linkages with other railway investments, which is important to consider. So these are many limitations and important limitations and footnotes that I make here, but this is not to say that the CBA exercise in itself is not of any relevance, because we can say that already now we collected a considerable amount of information. We also had like many iterations, many validation exercises with many of you, and we believe that already at this point the CBA does provide the insight in the direction and the magnitude of what can be expected from DAC. So with this in mind, we can move to the next slide. What you see here is still an overview of the steps that we're working on and that we will see implemented in the CBA model in the course of the next year and a half. So additional use cases, information on the maintenance and reliability of the final design, information on administrative costs, the final implementation strategy, etc. So this is important to take into consideration of what still will be changed. On the next slide, you will find some information on what is not included in this CBA yet. Primarily, what I want to emphasize here is that we didn't allocate benefits and costs to specific stakeholder groups. But having said that, we are now, as of now, working on developing case studies for specific companies, and we also will touch upon this at the end of the presentation. Looking at results, we can go to the next slide. Here you see the main overview table of the CBA model. On the horizontal lines, you see the different tech packages you might recall. So we have different groups of components that lead to different savings, time savings, because you can have the automated brake test or the train inspection being automated, which reduces times, increase benefits, but also these additional components also have a higher cost, right? So it's always a bit of a balance between the cost and the benefits. And so each tech package has the horizontal lines, and then you have information on the start of the implementation process, when the Big Bang occurs, and what the rolling stock scope is. Afterwards, you see information on the total benefits over this 30-year period. On the second from the right column, and on the last column, you see information on the impacts of DAC in a 10-year period. So what I want to emphasize here is that in all of the scenarios, we look at a positive benefit cost ratio. So in tech package 1, you see there on top, it's like 1.5 in a 30-year period. In tech package 4, we look at up to 2.8 benefit. So that means that for every euro that you put into it, you get 2.8 euros back in this 30-year period. So that is for an investment program a quite attractive ratio. At the same time, it also should be said that on the short term, the investments are considerable, and the benefits only materialize after a period of time. So it also shows that there is a gap in time when the impact in terms of cost will be enormous and the benefits will, are still relatively low. So this is an important input also for the discussion on financing and funding, and how that gap needs to be bridged. So on the next slide, you see some more information on how these benefits and costs are divided between the different elements. And okay, there's quite a bit of information here. Let me just focus on the essence. As said, the CBA, it's not a business case. We do not look only at the benefits and costs that are specific for one railway operator or one wagon keeper or one IM. We look at the impact on society as a whole. So we also look at externalities, like emission reduction, like noise reduction, congestion reduction. So all the benefits for the transport system and society as a whole. And in the current version, I think when looking at the tech package 4 results, we see that this is about 1/3 of the benefits are related to those social impacts. Then when we look at the time-related savings, so that's not only the coupling and uncoupling, but also the time savings that are being enabled by the digital component of the DAC. We look at about 45% in total for the different train segments. So for the block trains, intermodal trains, single wagon load trains. And then we come at a few other elements in benefits in terms of hardware savings and utilization related benefits. In terms of costs, yeah, clearly the bigger costs are linked to the investments that are needed for the coupler, the components itself, but also for the renewal of components. And for now, the EDDP put forward that each 12 years, the components that are fitted need to be replaced. So that also implies like 2 replacement cycles in the 30-year period, which amounts to rather high costs. So these images gives you a bit of an initial feeling of where these costs and benefits are laying, and yeah, that's also helpful to interpret the relative benefits and relative costs for the different stakeholders. So this summarizes the main results. I think that now we can move to the detailed results. And with that, I would like to first give the word to Nicolas, who is going to inform you about the costs. And afterwards, I will take some time to guide you through the detailed analysis of how we calculated the benefits. So thanks for now. And Nicolas, please, floor is yours.
Thank you very much, Michel. So in this presentation on the costs, you'll see that there are two different kinds of parameters. You have, I would call them overall economic parameters, dealing with the total EU rail freight traffic, the fleet of wagons, the fleet of locomotives, and the migration scenario, which has been used in the analysis, and then the unit cost, which are used to assess the total cost of DAC deployment. That's the overall logic. So first of all, when we are talking about the EU rail freight traffic, it's a bit challenging. We have been using some European statistics, Eurostats, but sometimes also we've been cross-checking these statistics with national statistics. And usually you can find some information on ton kilometers overall, considering block, intermodal, and single wagon load. The trick is that for our calculation, we needed to split this total traffic by category of traffic, block, intermodal, single wagon load, and also to assess the number of trips. And this is where it was a bit trickier. So where we had to take some assumptions and to look for additional data, which are not available in EU or even national statistics, but in a few unlimited countries. That was a huge part of our work at the beginning. So if we go to next slide, for instance, then we have been able to recalculate the train counts per country. You can see the weight of Germany on the overall rail freight traffic in Europe. Germany is approximately 1/4 of the total rail freight traffic in Europe today. And so we've been able to have this assessment of the train counts, because in the end, what is important for digital automatic coupling is you look at the train counts, you look at the number of coupling and coupling operation as an average per train, and then you can multiply by the number of operations for the calculation of the benefit of the coupling operation without DAC and with DAC. If we go to next slide. Transport forecast. So also, we know that we've been, through the consultation, we've been receiving many comments on this, on those assumptions. Just a reminder on the methodology. The objective of CBA at EU level, because also the CBA is done under the umbrella of European Commission, is to be able to compare different investment projects between each other. So it's very important that we have, I would say, a consistent set of assumptions between the different projects and for the assessment of the different projects. So even though there might be some doubt on the achievement of the EU Green Deal objectives, which foresee a doubling of the rail freight traffic by 2050, it's important that we stick to a consistent set of assumptions with other projects which will be assessed at EU level. And so this will give DAC CBA a result which is comparable with other EU projects. And this is also a very important point. So a few more words on this doubling of rail freight traffic. We can see that intermodal is expected to have the highest level of increase, and this is also aligned with the feeling of stakeholders. Block trains is expected to have the more limited level of growth, of course, because also for block trains, you have some market segments which are not expected to increase and even decrease in the coming years, like coal. And for single wagon load, as DAC is expected to significantly improve the performance of coupling and uncoupling operation, DAC is seen as a great opportunity to redevelop single wagon load at EU level. So then it's split per country, as always, all this forecast. if we go to next slide, then we have the assumption on the total fleet of wagons which have to be equipped with DAC. So total fleet is estimated at 460,000 wagons in Europe, and then it's split in two different categories linked to the migration scenario. You have the core wagon load system, so it's wagons which are going sometimes through a single wagon load system, and therefore which would need to be coupled and uncoupled very often. And then you have the non-core wagon load system, where you have train composition which are not changing so much in operation. Like for instance, intermodal traffic, we know that the composition are usually not changed unless you have to repair a wagon, or also some block trains which are working on a specific lines and specific traffic, and those block trains are not changed very often, the composition of the train, so the coupling and uncoupling are very limited. So this is why this fleet is split in two, and we'll see that in the migration scenarios, there are two different paths for the migration between core wagon load system and non-core wagon load system. The core wagon load system are going through the Big Bang process, whereas the non-core wagon load system are going through a smoother and not so intensive, I would say, migration scenario. Next. Then also you have all the assumption on the rolling stock and locomotive. So as we have to equip the locomotive. On the locomotive side, as we can see, the locomotives are quite old at EU level, especially diesel mainline locomotives and shunting locomotives. So a significant part of the locomotives are expected to be equipped through the renewal of the fleet. And another part is expected to be equipped, especially for electric mainline, will have to be retrofitted. So far, and I think it's been already raised in the migration discussion, migration workshop, we missed some information on the potential cost of migration for locomotives, especially on the complexity of operation for migration for equipping locomotives with DAC. So there is an important work which is ongoing to collect some extra information on the locomotives in order to better assess the cost in the near future of equipping them with DAC. Then migration scenarios, so I'll go very quickly on that. We can skip this slide. I think I will just comment the next slide. Yes, so we are going for the 6-year migration scenario, where for the core wagon load system, you have a first step of preparing the fleet, so to be kind of DAC ready, and then to go for the Big Bang, where we can see the sharp increase in year 4 and the year of the Big Bang, where you go through the so-called vaccination center, where we go for a very, very quick migration in a few weeks to equip the wagons that will be prepared beforehand, and also the supplying of the DAG will have to be done before, and the vaccination center will have to have all the material ready to do this Big Bang. And for the orange part of the migration scenarios, this is the non-core wagon load system, which is affected there. And as discussed before, for those ones, we can have a smoother and more linear progress towards DAC migration. I won't come back on this again because it's been discussed before, but that's what has been done in the CBA so far. So we discussed all the one part of the multiplicator before, which is the number of vehicles which have to be equipped. Now we are talking about the unit cost applied to all these wagons and locomotives. For the CapEx, first we consider the coupler cost, and for the coupler cost, we are considering a unit cost of 5k euro per unit, which is the assumption as it is today. As a reminder, we have 2 couplers per wagon, so it's multiplied by 2. And on top of that, we are considering the cost of mounting the coupler on the wagons or on the locomotives. There are 2 different situations which have been considered in the CBA. We have some basic situation where it's easy to retrofit the wagon or the locomotive with DAC, and we have some complex situation where the design of the wagon or the locomotive is not, I would say, DAC ready or easy to retrofit the vehicle with DAC. And so for this complex situation, we consider much higher cost of mounting DAC on the wagon or the locomotive. And we're also considering a small administrative cost on top of that, as we expect one of the, I would say it's a design to cost process which is done for DAC, and there is an expectation to have a smooth process and an easy process for authorization for DAC retrofitting and equipment. We go to next slide. We also consider some extra cost. So we have the cost for new wagons and locomotives. As I said before, sometimes you will have to retrofit the fleet, but there is also a small share of wagons, but a much higher share of locomotives, which will be equipped through renewal. So we will not equip, retrofit all wagons or all locomotives. They will be replaced, and they will be replaced with directly equipped with DAC. As we consider that DAC is more expensive than screw couplers, there is an extra cost which has been considered for these locomotives and wagons in the analysis. And there is also an extra cost which has been considered for wagons which are not going to be equipped with DAC because of the complexity of the operation. And for those wagons, the costs are linked with the cost to isolate these specific wagons from the rest of the fleet, and the transportation cost associated for this isolation process, and also the loss of economic value of those wagons, because it will not be possible to use them everywhere in Europe as it was before. Then also, very important part is the additional components, because DAC will enable some benefit, but DAC is also an enabler for additional functionalities and use cases, as been described in the overall summary before. So here it's just a presentation of the total cost of deployment of additional DAC plus additional components according to the different tech packages which have been presented before. And I just put a few examples. There is a full list in the presentation in the consultation document of all these additional components and corresponding cost. But for instance, you have automated air valve, automated brake test, some wagon telematics, some train integrity control system, etc., which can be deployed on top of DAC on the wagons. And these costs, of course, have been considered in the analysis because they are required to achieve the expected benefits. Infrastructure and IT systems. So for infrastructure, because of DAC, we'll have to change the bumpers at EU level. So there has been an assessment of the total number of buffers at EU level, which has been made. It's estimated as approximately a bit more than 80,000 bumpers. So the calculation is quite easy, and it's for infrastructure. It's an infrastructure manager cost, and it's a multiplication of the number of bumpers per this unit cost of 5k euro per bumper. And also there is a one-off cost which has been considered for railway undertakings, one-off cost dedicated to the modernization of the IT systems, because we consider that the existing IT systems will not enable railway undertakings to reap the benefit of DAC. Therefore, there is an extra cost of 600 million, which has been considered at EU level to modernize the existing IT systems of railway undertakings to take advantage of all the functionalities of DAC. Okay, these two lines, it's just 2 lines, but it's very important. It's a recurring cost, and it has been considered in the analysis that the cost of maintaining DAC will be higher than the cost of maintaining screw couplers. So this assessment at this stage is preliminary or provisional. It's 300 euro per wagons and 200 euro per locomotive. In the end, it looks small in the CBA, considering the total fleet and the total number of years. It represents billions of euros. So, and it's been considered in the CBA. So there is definitely a significant part of increase of OPEX, which has been considered in the CBA. And then one-off cost, okay, some extra one-off cost. You have some. It's a cost of scrapping wagons and locomotives before the targeted end of life of these wagons and locomotives, because we consider that it's not worthwhile to retrofit them with DAC, so it's better to scrap them and buy new wagons and new locomotives. So a cost has been taken, an assumption has been taken on this scrapping value for wagons and locomotives. So far, just to be completely transparent, we still miss the assessment of the number of locomotives which will be scrapped. So the value for the locomotive fleet is set to 0 at this stage. But as Michel said before in the presentation, these assumptions are expected to be updated in a second iteration of the CBA, and we do not expect that it will have a dramatic impact on the overall result and the overall equilibrium, I would say, of the CBA. Then also loss of revenue during migration. So there's been a detailed assessment of what could be accepted as out of operation time for the wagons and for the second wagon load system. So basically, it says if we go for more than 4 weeks out of operation, we just kill the single wagon load system. So this is why also that was an important factor in the design of the migration scenario. We have been having some extensive discussion on the potential loss of your revenues during migration. So far, this loss of revenues has not been considered in the calculation. We have everything ready to include it in the CBA file, but it's not considered because we could not collect some robust assessment of this loss of revenue, because it's very complex. You have to consider that are you really going to lose some revenue? Are you going to lose some profit margin? Can't you just subcontract your operation to road operators during migration? This is some complex issues which have not been explored totally so far, and which will not need to be fine-tuned and rediscussed with operators before putting a figure. And overall, I would say that we've been faced with Michel and Jens during this exercise with a choice between comprehensiveness and robustness, is what I always say. And sometimes we had to sacrifice comprehensiveness for the sake of robustness, because just putting some assumptions out of our mind without some evidence to defend them was worse than putting nothing at some point, we believe. If we go to next slide, I think I'm done with the cost, which I'm sure will raise plenty of questions at a later stage, but I leave you the floor, Michel.
Yeah, thanks, Nicolas. And maybe to add on the one-off cost for single wagon load, it was used as input for the migration program, and the emphasis is also on reducing the spirit as much as possible, so there's no rupture in the general processes. But the migration scenario is still under development, and any update on this we also will integrate in the CBA. Now, to move to the benefits, evidently the most interesting and biggest benefit of DAC relates to the time savings, and we put quite some effort into analyzing this. So as you see on the next slide, the thing is that DAC is, well, expected, reason to believe, reason to decrease the time of shunting activities, but also in the preparation and the departure of the train. It's not only the coupling itself, it's also the time savings that are enabled by these components, like the automated brake test and the train inspection. So in order to understand better, like what DAC would imply in the field, we first wanted to have a better understanding of how long the operational processes in different sites take today, and then to conceptualize how much time savings can be expected if DAC will be introduced. So on the next slide, you see the conceptual framework that we use to first distinguish the different segments in the rail freight business. So we looked at the single wagon traffic, at the block trains and intermodal trains. And single wagon load traffic is, as you can see here, also operationally the most complex, because you collect a large amount of wagons from the different sidings, bring them either to a small marshalling yard, maybe followed by a big marshalling yard, and then at the destination there is the more complex uncoupling and the delivery process. For block trains, we also had the step with customer siding, departure siding, taken into consideration, and with intermodal trains, here in the process view, it seems the most straightforward in terms that you have a run from terminal to terminal. For these three segments, we looked at how much time it takes for all of the sub-processes. So together with many experts, we try to distinguish all of the sub-steps that fall under the train arrival, the shunting, the preparation, and departure process. We had discussions with this with about 14 organizations, and 9 organizations, they provided us with detailed information on how much time it generally takes for each of these sub-steps. And these 9 companies represent about 30 to 35%, depending on the market segment, of all European rail freight. So with this, we believe we have a quite good understanding of what time it takes all across Europe. There are some gaps in countries, but overall, I think this is a quite impressive and important work that has been done here. Now, on the next slide, you see the overview of the outcomes, and you see each bar represents one company, and the numbers represent the hours that it takes for each of these sub-processes. And on the upper left side, you have information on the departure and on the sidings. Then on the right, you have some small marshalling yards. Down on the left side, you have information on the combined transport terminal, and on the right side on the big marshalling yards. So here you see the information of all the companies, all the hours that it takes. And what we did is we looked at the share that each of this company represents of the total EU traffic, and we used that to estimate the weighted average, the weighted time average. So on the next slide, you see that we took this weighted average for the baseline scenario, and then we made the next calculation where we estimated how much time could be saved thanks to each component and through the different couplers. So with the Duct 4 coupler and the Duct 5 coupler. And by doing so, we made the comparison between the baseline scenario with the numbers that you saw before and this assumed time savings with Duct with the different tech packages. And that brought us to a total number of hours of time saved in the European rail system. Now, that is already a very nice insight, but that is not enough, because in the Duct we want to monetize the benefits and the costs. So it is important to translate this time saved into money saved. And here comes the difficult point, because we could say that we are way faster in the sites, but that does not mean that the train is able to necessarily true that the train is also able to leave earlier, because there can be bottlenecks on the network, or a slot has not been assigned, or there's another issue. So we need to consider that an hour saved does not necessarily lead to actually an hour effectively being used. At the same time, we also do not want to say that we save all these amount of hours and the railway system as a whole, it would not be capable of becoming more efficient. So we want to find a good balance between what is plausible in terms of time savings and in terms of monetary benefit that this would imply for the railway sector. So for this, we try to dissect what kind of monetary benefits a time saved would lead to. And on the next slide, you see this over, maybe one slide further. Oh, wait, exactly. Yes, here we still have like the total time savings, which is important still to emphasize. So on the, you can go one slide back. It's let me stop here. Yeah, exactly. So on slide 62, here you see the time savings that we calculated. So for the baseline, this is this weighted average from these 9 different operators. And then we come to the assumed time savings on the different project scenarios with this tech package 1, tech package 2, tech package 3, and tech package 4. With the tech package 3 implying that you have this automated brake test, and with tech package 4 having this automated train inspection. And we are still calibrating like how much time savings can be expected, but you see that already as of tech package 3, the time savings are very substantial, and I'm not even speaking of the time benefits that can be achieved with tech package 4, which is an enormous difference. So understanding these time differences, then we move to the conversion factors. And here we see the dissection of what time benefits could lead to in terms of cost savings. And here we looked into savings in terms of operational staff and in terms of assets like a shunting logo, a mainline logo, and wagons, and also in terms of savings of the mainline driver. And on the next slide, you see that these are the numbers that we applied. So here we have the monetary value of all of these sub-elements, and on the right side you see the percentage that we take from this value to come to a real or approach benefit of what 1 hour saved implies, leading in the end to an average monetized benefit of time saving for block trains of 145 euros an hour, and for intermodal trains it's 135, and for single wagon load it is 140 euros an hour. So we multiply the total hours saved for each of these segments with this number, and we realize that there are differences, strong differences for some of these elements in different European countries. But at this point, we wanted to make an assessment first on the European level, and later on in case studies, we can have a closer look in what it would imply for different countries of different companies. So that was the overview of how we assess the time savings and how we monetize these time benefits. But we do not only have those benefits, we also believe that there are quite some benefits in terms of capacity. Now, we have capacity in terminals, which is also one benefit that has been confirmed to us by quite a few organizations. Currently, the railway network is already experiencing capacity issues, and it also is already the case in some terminals and will be the case in the future, considering that intermodal transport is growing by 6 to 7% annually over the last 10 years. And also in our forecast, we foresee a very strong growth of this segment. So you have more trains coming in and out the terminals, but in the end, it's full. And when it's full, you have an option. Either you invest in new material or you invest in wholly new terminals, greenfield terminals. And the cost of these terminals runs above the 100 million euros. Assuming that with DAC you have more efficient processes, that the trains leave the terminal faster, meaning that you can also have more trains coming in and out on a daily basis in each existing terminal, implies that you need to have fewer terminals, fewer investments in terminal capacity for this for the future. So in our CBA, we try to estimate what the benefits would be of this increased capacity, and by doing so, we monetize the benefit of DAC for saved investments in terminals. On the next slide, you see some information on the capacity benefits in terms of trips saved. And yeah, let me try to explain this. The screw coupling, the strength of the screw coupling is now today already in some cases the blocking factor for having longer trains or for loading the trains with more material, with more goods. So already today we see the limiting factor of the screw coupling on the capacity of trains. The duck will have stronger strength, meaning that we can have, simply by having the duck, already either longer or heavier trains. Now, it's not only because of the duck that you can determine whether a train can be longer or heavier. It also has to do with infrastructure limitations. Some segments you simply cannot have a train that is longer than 500, 600, let alone 700 meters. So that is a limitation. We also need to take into consideration the topological characteristics. If you have like steep inclinations, it's also not so straightforward to have heavier trains. So the extent to which the stronger couplers can actually lead to heavier or longer trains is very much country dependent. Now, it's also for many countries difficult to assess actually what it would imply, because it really implies a deep dive in the data to understand to what extent the screw coupling is the blocking factor. But a few countries did this exercise and they gave us some numbers back, and you see that for Austria these figures are rather limited, but they saw a few cases. But here we really talk about a low percentage, like 0.04% of total capacity could be increased. In Germany, it's already approaching the 1%. In Italy, it's even larger. In Portugal, we still have to correct this figure. This was an initial number given, but this number needs to be adjusted. It's not a single country that high. But there are also many countries that couldn't assess it at this point. We believe, therefore, that this benefit is larger than what we could assess at this very point, but we're still waiting for additional input from countries to estimate this, and we are rather careful with making assumptions on how big this benefit really could be. So yeah, it's in line with what Nicola was saying before. Like, we prefer to focus on having robust data rather than making too frivolous assumptions. But this is an important aspect. Then we come on the capacity of the infrastructure itself. And this is a bit of a tricky one, because let me go back to the sustainable and small mobility strategy. So this policy objective is to double rail freight by 2050. But I would not be the first one to say that doubling rail freight with the current infrastructure in itself is already a hell of a job. So the question is if actually there is enough capacity to cope with so much rail freight traffic. Now, we assume in the CBA that there will be a considerable amount of investments in the railway system. We assume that ERTMS level 3 will be put in place. We assume that there will be large investments in the TEN-T network, both in additional tracks and the improvement of the existing tracks, like improving the gauge to P400 standards on many segments. And those are very important assumptions that are a prerequisite for enabling this doubling of rail freight. But DUC is also an integral component of this strategy, and we wanted to understand what share can be of this growth, of this additional capacity, can be attributed to DUC. Now, on the next slide, you see some information on a small survey that we run, because we also were actually curious to understand how the situation is today and how much capacity issues are a limiting factor of rail freight. And admittedly, it's a very small sample, but still it is insightful. So all of the RUs that responded to our survey indicated that they experienced capacity issues. And what is more, that they also gave an estimation of how much more they could, how much more transport they could provide if they had the slots available. And this runs from 15% for block trains to up to 26% for intermodal trains. So it really strongly shows that capacity is a key issue and that needs to be resolved. Now, then when we look at the role of DAC, we try to estimate it in this figure. So we have this objective of 100% increase of rail freight by 2050, so meaning a doubling, and DAC is understood as an integral component of this. Now, what we did is that we understood that from work package 6 in the EDDP, the DAC delivery program, that the theoretical maximum capacity increase could be 30%. But we try to be very conservative with this, and we also want to acknowledge the interaction between DAC and other technologies like ERTMS. So what we estimated in the end is that if DAC would not be implemented, you do not reach this policy objective of 100%. Instead, you will arrive at a lower point of 95%. So you don't have 100% growth, you have 95%. And this difference also can be, this benefit of additional capacity also can be then assigned to DAC. So it's a bit of a theoretical exercise, but it's a very important assumption that is embedded in the model. So on the another point related to the savings, and here we come to the trackside savings, and this is very much linked to the ongoing developments in ERTMS. So in order for ERTMS level 3 to work, you need to have train integrity monitoring on all trains, so also freight trains. Now, for the time being, there are a few alternatives, but DAC is also a technology that enables train integrity monitoring on freight trains throughout Europe. So by doing so, it is a facilitator and an enabler of ERTMS level 3. In the CBA, we made the assumption that not all trackside train detection hardware needs to be removed, because you still might encounter situations where you have, well, degraded monitoring, or there might be some shunting vehicles without ERTMS. So in the end, you will still end up in a situation where you still have some track circuits or axle counters still in place. But overall, there will be a substantial reduction of the train detection hardware, and that means that there will be a substantial cost saving, which is enabled by, well, to at least partially by DAC. So we estimated the savings that follow from this, and we also included this in the CBA. So it's an important additional benefit of DAC that we looked into as well. In terms of safety, and here I have to be cautious, because this analysis is, well, very tentative. We really need to look into the final DAC design, what it implies in safety, and when safety benefits will accrue. But the overall assumption is as follows. Now you have manual screw coupling operations in the sites with the risks for the staff. With automatic coupling operations, this risk will be greatly reduced. So you will have fewer serious injuries, fewer fatalities in shunting yards, in terminals, in sidings, and this needs to be also considered. Moreover, with the increased coupler strength, and potentially also with the derailment detection device on board the trains that are fitted with DAC, you will have a drastic drop in derailments. And also these derailments, derailments that are prevented, has a monetary value. So for the time being, we included some placeholder values, but we see that this will be updated in the year to come, so that you can give a more accurate assessment of what the safety benefits of DAC will be for Europe as a whole. Moving to the next point on indirect benefits, and as I was saying in the beginning, this is a very important point because it constitutes about over 1/3 of the total benefits. So the reasoning is as follows. Because of DAC, you will have faster train operations, you have more reliable train operations, and these improvements, they have a monetary value. Rail competes with road transport very fiercely so on many segments, and shippers have always the choice to choose, well, in many cases, the choice to choose between road and rail transport. If the price competitiveness and the overall competitiveness of a rail product improves, it becomes more attractive for a shipper to move its goods by rail. And this shift that will then be induced by DAC because of the price and quality benefits will lead to an overall modal shift throughout Europe. And we see that this shift is mostly linked to the intermodal transport and single wagon load transport, which then would have a higher market share because of the shift from road to rail. Because rail is substantially greener, is substantially less impactful in terms of externalities as a whole, and then we talk about emissions, then we talk about noise, then we talk about congestion impacts, there is a monetary value attached to each ton of goods being moved from road to rail. For instance, because the health impacts on society will be lower, because the road maintenance will be lower for governments. So these benefits related to the modal shift are very important to consider from a societal perspective. In order to approximate these benefits, we were lucky that we could build on a very elaborate study. It's been performed by CE Delft in 2019, and it's the handbook on externalities, on transport externalities. And there they calculate for each mode of transport for the different categories what the difference is between externalities for the modes of transport. So we looked at the difference in terms of social impacts from road transport and rail transport per ton kilometer. And we looked then in the total modal shift that can be expected from DAC, that is being induced by DAC, and then multiplied this modal shift by this difference in externalities. So this delta between road and rail cost of externalities. And by doing so, we could estimate what for society as a whole, the introduction of DAC would imply. Now, when we just focus on the CO2 emissions, we see the following figures. We see that for road transport, there are about 137 grams of CO2 per ton kilometers, whereas for rail transport, it is 24 grams CO2 per ton kilometers. So knowing also the modal shift that is implied by DAC, we could make an assumption on the CO2 savings that will be enabled by this technology. And in total, we come to about 140 million tons of CO2 reductions over a 30-year period. A final analysis that we did relates to the energy savings, and that's what you see here. For this, we wanted to see how much energy is needed to transport a ton of goods over 1 kilometer by road and by rail. And because, again, we know what a total modal shift is that's being enabled by DAC, we could look at this delta, at this difference between road and rail, and estimate how much less energy you need to transport goods over the period of time in our study. And in total, we came with this first calculation to a saving of about 313 terawatt hours, which equals the annual energy consumption in Italy. So over a 30-year period, over 25-year period in all of Europe, you would end up with a saving that equals what is being consumed annually in Italy. So What we try to do in this exercise is also to look at the overall social benefits and specifically highlight what it would imply in CO2 savings and in energy savings, as these are quite important topics nowadays. I think that with that, I have expanded on all the benefit elements, and I think now is a good moment to give the word to Jens for some concluding remarks and providing the outlook.
My dear colleagues, many thanks. I am deeply impressed. We are 11:20. You have 20 minutes left from your planned time. And if you ever want to employ someone, or if you have the need for someone who can explain 60 charts in an understandable way in 20 minutes shorter than foreseen, please go back to the two gentlemen here. They can be of a help, is my impression. So this was great. Thanks very much. And hopefully this was understandable for you. And I see, you see the applause, this is yours here. You see how much work went into this all. And this doesn't mean that we are at the end of the story. We have some questions in the chat, and certainly questions in Slido, maybe because it's helpful here. Peter Jinra from the GD Cargo has asked, and I will maybe pick this immediately because it's a clarification question, that for the division between costs, I think this was Nicolas' slide, there is the assumption that light blue space bottom on the left, that the DAC needs to be renewed every 12 years. Nicolas, I think you can see the comment in the chat, yeah.
I'm not the best guy to answer this way. I think I want the comfort from Michel. From my understanding, from what I remember, it's only extra components. It's just DAC, but I want to have the validation from Michel. Exactly.
Yeah, I can confirm
please,
it.
Please,
so these are only the additional components that are now being seen as to be replaced to be every 12 years.
No.
Just to say, this is like an indicative initial number. We need to assess like for later on for the components still what their durability is. But for the components, we have set this now also to be conservative on the financial needs for component replacements. Now, the coupler itself, the durability, the lifetime is considered to be way longer, and we do not foresee a replacement within the time frame of the CBA. We do see maintenance, as Nicola was saying, like about 300 euros a year per wagon, but no replacement of the DAC.
Mm-hmm. Yeah, many thanks for this clarification, because it also shows that, as you mentioned many times, that you are always conservative on the safe side of the approaches. And if this is for these additional components, then it means that electronics might be outdated, worn or whatever after a number of years, and that you just have to replace it as you replace your smartphone from time to time. Yeah. And then we enter in a recycling discussion. And that means if we don't consider these costs, we would maybe make a wrong assumption. So we are here absolutely on the safe side, and hope, Peter, that answers your question. I see a thumbs up very much. Thank you very much. Yeah, okay. And that means now with this picture here, and as I said in the beginning, we are not yet completely perfect. And we have also from Jürgen Meyer, thanks very much for this question here in the chat, something that I also want to answer directly on my next page and over next page. Because you have maybe seen and noticed what Michel has said on the results and the total results, that on the 30 years average and long run, this is a very good benefit cost ratio. And on a 10 years perspective, and this was a long discussion within the EDTP, on the 10 years perspective, which is the business perspective of companies, you have to have a payback within 10 years. Normally you have to have it even earlier, which is now a little bit difficult. If you invest now for 6 years and then you want to have a payback in the next 4 to 3 years or whatever then comes afterward, this is economically a little bit challenging. And this is also why, and I come back to that later, we have the precondition that this will only work if the overall situation is sufficiently supported financially by someone. The degree of necessary funding is still on the way to be calculated, and I will come back to that also in a moment, because also business cases and individual company examples, as Jürgen Meyer suggested here in the chat, are exactly part of this picture. Now, what are we doing to take this up here and that you see how this will develop in the future? This is the foreseen, I mean, it's already the decided structure, but at least not yet fully stuffed, but this is how we want to do it. This European Duct Delivery Program, this is the part in the middle, the EDTP Neo, yeah, the new one. This will focus in the next years mainly on this implementation and migration, how to bring that into the field. And you see here different green boxes containing fleet analysis. Nicola, you mentioned the analysis of the locomotives. This is, for example, something that goes on more in this box, in this field. Workshop capacities, can we move to the customers? What is the operational plan per country and so on, to dig deeper into that. We also have, since many meetings, we know that we have the question of unrefurbishable and unretrofittable locos and even wagons, what to do with them. There will be a remainder, a part of them. Where can we keep them? What can we do with them? This is also impacting the CBA. There are certain assumptions in for not using that, but we don't know exactly how much. And you see also here in the middle CBA updates. And as now all the technology development is done, as I said in the beginning, in this left column, which says Europe's Rail Flagship Project 5. Can you see that on the left? Yeah. And here's the development of all the technology until the maturity level for deployment. They will, over time, find out better what are the real production costs for a coupler. What are the retrofitting times for all this technology? How much holes do I have to drill? What do I have to install? How long does it take? Is it just a throw and forget or whatever? So these indications, they come out of the development project and they will feed back into the part of CBA updates in certain rhythms. Michel, Nicolas, I think we have agreed that something like twice a year or so there should be an update, a minimum once per year, so that we come always closer to the reality before we come to a investment decision. And in these updates and CBAs, including the building up of the proper funding and financing plan, where we have many people here in the meeting, I take as one example Matthias Knüppling from VTG, are really fighting hard for getting a good model and a good way to do, a good structure, how to do it, in which we could then distribute the money necessary for the deployment. This is also part of the future work. And then also authorization processes, because we have an idea on how to make Big Bang feasible for the mechanical part without reauthorization. This requires a certain huge upfront work, but we have, for example, not yet an idea how to do a reauthorization or no reauthorization for the electronic parts, because that is also sometimes and very often still in the hand of the national safety authorities. And then we would have a hindrance, an object, and a burden in migration, which we even have not factored in at the moment into the CBA, because I mean, it's simply unimaginable that Europe would have to wait for the reauthorization of something like 200, 300, 400,000 wagons. Then we can leave that, and we can forget the whole exercise. That means also here TSI revision and authorization procedures are important elements for refining better. There is somewhere a train in the meeting. No, it's close. Thank you. I think it was Johannes Kleber. And the I don't go more into details of the system pillar and so on, because it doesn't matter. But you see here, the middle machine is for implementing, and the left machine is for providing the further data, which you don't know yet. For example, these 5,000 euros per coupler or not. And I come to the last slide from me, and this will also then answer partially the question of Jürgen Meyer, because we have put, after so many discussions, some prerequisites, some preconditions on all that. So we will not have just a good positive CBA over 30 years, and then we say it's in a TSI, and that then everybody must do it. That will not work. This is a full sector transformation, and that means we have here from 1 to 6, we have first of all, number 1 and 2, the duck ready, and it has to be proven as a technology. It has to be reliable. It has to work. We have had so many comments from many sides saying, yeah, please, you cannot be worse than the screw coupler system with the reliability. And I mean, it's fully true. You cannot accept that a train stops every 500 meters because there's a mismatch in the contacts or something like that. Then we are worse than before. So this needs to become out of this flagship project, and we need to have the target reliability. Also, number 3, the operational functionality. That means that all these benefits, these use cases really provide the benefits that we have, that Mitchell has shown from the time gains and so on. Yeah, but this needs to be tested. The number 4 is the adequate funding available. Jürgen, your question, this is certainly not possible to launch something without having that. But for this, and here now my remark and my request to all of you, we would need more examples from you. This was also a part of the user consultation, a question in the user consultation. Can you join the team here for making some more exactly here, this is the result from the user consultation, where you see that the blue and the light blue and so on is overall an agreement with what we did here. The red is, we don't know yet, we doubt on the values, on the benefits and so on. And here we said, okay, please focus notify to us that you are willing to make a company example with us, where we calculate not the CBA, including the societal benefits, but really the company business case, so that we know how big the gap is that we need for support, and what the time is in your case, and if it specifically helps you or not. And here we want to do, Michel, as I don't know, half a dozen examples to be better and to make that better substantiated in the near future. And there also we have to deal with these facts that we have sometimes very old fleets, 40 to 50 years old, and we have to think what are the models if we want really to retrofit wagons which are 50 years old and maybe they go out, or if this is maybe better supported by a kind of scrapping bonus for purchasing new wagons, which is a different kind of funding. Okay, and with this, I would say that is more or less our intention, how we want to be serious on all that. And now 11:30, we are like a wonder. We have half an hour left for all the questions and answers that might have come up. And for this, I would say thank you very much to the presenters. And Peter, I have to rely on you, because I think you have collected all the questions for us that you might have typed together. Let me know how we can go forward to answer now, because now we officially open the question and answer session. Okay.
What I will do is, we have collected all the questions here at Slido. So I would request to just go through the question, pretty much question by question, as they come in. All the questions from the chat, which occurred until now, I also copied into the Slido poll.
That's perfect.
So I would just say we start with the first question, which is this one here from Maria.
Is it the right side here, what you see? Because for me, it's on the, yeah?
Yes.
Okay, can the Vademecum model be used in this CBA? Does someone, Nicola or Michel, know what the Vademecum model is?
No, I'm not aware of this one.
I know that the Commission has a few vademecums, but is this also related then to the DG Regio approach? If that is what you mean, I can say that we align the CBA approach and some of the assumptions, like the discount rate, with what is being stipulated by the European Commission, also to ensure consistency with other investment projects that are being organized on the European level. So if that is what you mean, then I can confirm that there's an alignment. If you want to clarify, if not, please put in another question.
Yeah, thank you. And also, or you can also ask that maybe Michel via email after the meeting.
Exactly. We're gonna send out all the answers, and if there are further questions, you can also sort of ask them after the meeting, and we'll come back to you. The next question: some countries use tail lamps.
It's interesting. It's interesting because we have this old discussion here about tail lamps and tail plates, you know, and now there has been a decision after so many years of discussion that is reduced down to one plate and one lamp model. And if you have now a duck which knows the train integrity, and you want to avoid that someone walks out to the train and there is no one anymore to walk out to make a brake test and wagon inspection, or yeah, maybe for the wagon inspection we cannot fully renounce on the person, but in a future target state, then you will certainly not use anyone anymore to put a tail lamp at the end, because everything else is automated, but just a tail lamp you have to put manually. So this is certainly not a good idea. So we are reflecting about intermediate solutions, which is maybe a tail lamp, an LED or whatever that can be switched on the duct. This is under investigation. Certainly the idea is not to keep this as the last manual intervention here. And the and of course, the target state overall is to have this electronic train integrity function within the ETTS level 3. But for the daily life, I think we should reflect on how to make that possible. And this is also foreseen, if you see on the use cases list, this is already indicated. It's not yet under full development, but we will look deeper into this when we go to the processes of train run. Okay.
The next question is on another component, the buffers. But I think it has been
buffer stops. Yeah, exactly. Yeah. I think this, Michel, you have answered that. And
yeah, I can answer this indeed, because it was not in the presentation itself, but we did analyze it in the model. And I think, and now speaking top of my mind, we talk about something like 14,000 buffer stops.
No, it was in Nicolas' costs. It was 80,000 or something.
83, yeah, it's 83,000 the number of buffer stop.
Yes,
as we have put in the model. It's an assessment based on the data from Germany and Austria, where we could collect the data, and we made an extrapolation based on the number of kilometers of lines per country, as far as I remember, Michel. And then it's multiplied by 5k euro per bumper to make the overall calculation. And we will finance this upgrade. Financing is, the first stage of the CBA is to show that the project is interesting at EU level, especially for policymaker. And then there is a question of the financing, of course.
Exactly. And we are not certain that 83,000 is the correct answer. It can also be 60,000. It can also be 100,000, because I mean, this is, no one wanted to go walk around and count the buffer stops for us. So this is based on good assumptions. Yeah.
Yeah, it's the 14,000 that we got from Germany indeed. And like we extrapolated that to a European level.
Exactly. DAC 5 costs a little bit more than DAC 4, that's true. We have the assumptions somewhere in the costs, but what's the cost difference between DAC 5 and DAC 4? I think we didn't do this for DAC 4.5 yet, so this intermediate version with the electrical button. But in the end, I think it was 800 euros more for the actuator, regardless if pneumatic or electrical. So as far as I remember. Yeah.
Move forward, I check the cost of the actuator.
Yeah. So that means per coupler we said 800 euros more, and as you said here, the requester said, the person who asked the question, the rest is more or less software and is somewhere hidden in the authorization cost, but it will not cost more in the box, in the electronic box on the wagon. Yeah.
Brings us pretty much to the next question, which is related to costs in maintenance for the electronic parts.
But the difference in maintenance costs between electromechanical data coupler and wireless data transfer. Yeah, first of all, you have to say here, is a wireless data transfer possible? I mean, this is also still under investigation. If normally the Wi-Fi solution has been excluded for connectivity reasons, because you have to have a stable connection. And then the maintenance is maybe not even the most important thing, because the most important is that the train doesn't stop, and that the train can be initialized, and that we don't have the same problems as when we connect our headsets Bluetooth to the laptop. And this is why we all have cables here and not Bluetooth, because we don't want to have empty batteries and stuff like that. And so give us a little bit time for the answer on that. Normally we would not go for the wireless solution anymore, but for the safe cable. And the maintenance cost is certainly not the problem. The bigger problem would be if we have daily disturbances in operation that costs millions and millions and millions. Yeah.
I have the answer for the actuator if you want, Jens.
Please.
So it's 800 euro per actuator. So it's 1,600 euro per wagon, plus the retrofit cost, which is at 280 euro per wagon. So total cost per wagon is 1,880 euro.
Thank you. By the way, this is good information because current migration ideas also entail the assumption that we would then mount in the Big Bang or so the duck head together with the mounted actuator. That means then even the retrofit cost would not apply. And also no one knows if these 800 euros are correct. And this will be known from the flagship project 5 then. Okay, thanks, Nicola. Which failure rate assumed for automatic coupling in CBA? This is so extremely important. Now we are discussing a target reliability and availability and failure rate. And as I said in the beginning, we need to have at minimum the quality of the screw coupler. That means we can only allow ourselves on the total train function, we can allow, or we need a level of 99.99997, something like that % reliability. We have many people who have already in public often said, don't forget reliability is key. This is absolutely true. And the target reliability is at the moment more detailed within the flagship project 5 and the testing. All that has to prove that this target reliability can be achieved. In the CBA here, the failure rate is, Nicola, Michel, help me. I think
it's the same as now for the screw coupler, exactly. So we now assume that at least as reliable as the screw coupling, but this needs to be confirmed. And if there is a difference, then it needs to be acknowledged.
And I think we don't even need the sensitivity analysis, because if we have a technology which is maybe only 93% reliable, and then we want to forget it, I mean, then we don't introduce it.
Yeah, exactly. Then there will not be any positive benefit cost ratio.
And that's the same answer to the question. Thanks very much for arranging that, Peter, the sensitivity for losing contact while driving on the train. I mean, certainly, you know, from the United States, for their electronic braking system, I think they have a latency of they can allow 2-3 seconds of contact loss, because they are more or less driving slowly, you know, steadily and so on. And that's not so important, even in a tunnel. This you can't do in Europe, but we don't know if we can maybe allow half a second or 4/10 of a second of contact loss. I cannot tell you. This will be part of the technical development then. So this, I think we had from Peter the renewal of the electronics.
We have it.
But did I get it right that you reckon some digital content also available in the time span for your CBA, such as, yes, of course, yes, you got it right. If I understand your question right, and please the others help me, in the CBA from 26 to 30, so over the overall migration, we have the benefits in the mixed traffic, certainly only if you have data and energy on all wagons. That means if you, in the preparation phase before the mixed, then you have nothing from the digital, you have just screw couplers, and then you have the Big Bang. Normally then, all wagons should have power and data. That means from this moment on, you can use the digital components. As Michel and Nicola have explained, you can refurbish normally the block trains, the intermodal and so on, as of day one, provided the technology is available, including authorization. That means for the X%, 20, 30, 40% of the fleet that run in block trains and shuttles, you can equip them more or less week by week by week. That means you have, of course, then the benefits in a kind of steady curve. It's a line over the years, because this is then with each equipped train you can use the brake test. Okay, and this is why these benefits apply earlier than 2030, of course. I hope that I got the question right.
Just as a reminder, also it's completely marginal before 2031, and it's really starting to ramp up after 2031. Before it does exist, but it's completely marginal. It's very small.
So that's also what we have in the model, indeed. So it's not, the benefits are not linear with the amount of wagons that are fitted. No, we have like an adjustment so that the benefits are considerably lower than what you would expect from the number of wagons during that implementation time.
Which is also conservative. That means in reality, I expect to have the benefits earlier, but they are not taken into account here in the CBA in this way. Okay. Tim Ellerborg, current CapEx of the basis wagons, 5,000 per coupler and 780 installation. Are they still realistic? As we said, this will come from the FP5. We have the assumptions that we had over the last 2 years. We have no idea of steel prices. We have no idea of energy prices in the next years. We have no idea of inflation and how much that will remain. And this is why we need all these updates all the time. We also don't have the final product. We certainly will get now a product with the manual operation level on, and this what we called before buffer position and so on. And this will also have a cost impact. We can tell you more maybe by, don't know, summer next year or something. Yeah.
Maybe to complete and let Michel complete also, we are considering, which still has to be validated by work package 5, but we are considering some sensitivity analysis on this parameter because indeed we know that there is strong uncertainty on it. Just between us, we've already tested an increase of the cost, and of course, it's not changing the overall conclusion of the CBA.
Yeah, exactly. I think we have even doubled the cost, is it? Yeah.
Yeah, exactly. So that also will be in the next iteration of the CBA. So we have the sensitivity analysis on the cost, but we also will look at the sensitivity analysis of the forecast. So what would happen in a negative scenario where you have higher costs, lower growth of rail freight? Is DAC also attractive in that cases? So we already did some preparatory work on the cost analysis that didn't change the direction of the conclusion. And we also will publish the sensitivity analysis in the next update of the CBA.
Yep. So this is, and yeah, sorry, Nicola, please.
No, I was jumping to the next question on tech package, but if you want to finish this one.
Yeah. Only because, I would like a last remark on that. You know, these updates, we are waiting then from official information signed off by the flagship project 5, so that all the manufacturers and operators in the project agree that now the next communication after feedback from tests and whatever is now the next level that they want to really communicate to the outside. Yeah. When this will then be, we don't know, but this is why we made a sensitivity analysis, just doubling the price 10,000 and it still works. Now, tech packages. Shall we jump back quickly to the slides, or do you want to explain that orally?
Well, I can, if I meet, then we can go back to the slide. But as far as I remember, the logic is tech package 1 is what is DAC 4 plus the smallest number of components required to achieve DAC 4. Tech package 2 is DAC 5. Tech package 3, you take DAC 5 plus automatic brake test, and tech package 4, it's tech package 3 plus automated wagon inspection. That's the philosophy. Yeah.
Exactly. So we always start with the DAC 4. That means at least with the digital things. For example, you get the train composition calculation. You can calculate the brake weight and so on. So this is the minimum. The first tech package we don't consider a purely mechanical package. Yeah. And then the others is, as Nicola just said, always you add more elements that you have the delta of the benefits. And I hope that answers the question. Upfront administrative cost, this we don't have yet because we don't have yet the full process. For the mechanical part, these costs are respected in the flagship project 5 because that needs to be the build up of this big risk management table. That means the properties, the mechanical derailment, longitudinal force properties of all wagons and also partially locos, to know if we mount a DAC now in the middle and we don't have buffers on the left, on the right, if we still comply with the derailment limits. And the answer is yes, we will do, but we need some tests for that and we need some proof. And then we have at least a model ready where the costs are borne within the FP5. Administrative costs later on, I think this will be also then part of a funding discussion, how much each wagon keeper has to be supported for updating the configuration or whatever the documents. I don't know. But what we don't know yet is the administrative costs for all the electrical part. So no, this is not factored in, but I can swear you on an 11 billion project, this will not be changing the picture so much. Do the colleagues agree?
I think so.
Yeah, definitely. Okay, this one I can take. Well,
please.
We've already been working on allocation of costs and benefits, so it's still being fine-tuned and it's still a work in progress. So there will be an allocation of costs and benefits, and we are working on it. For the other direct benefits from wagon keepers, we've been discussing, for instance, some benefits such as less maintenance costs thanks to telematics and things like that, but there were some doubt from people we interviewed that this could be achieved. So in a conservative way, we did not consider it in the calculation, even though we would like to quote it in the end in a more qualitative way, but not consider it in a quantitative way at this stage.
I would even say that the wagon keepers are the ones who would, in the end, certainly benefit about better information on the wagons and so on, but they have to pay the higher transparency and the information with something that they didn't have before. They now have a coupler and they have electronic stuff on the wagon, and this certainly will cost more, as you have seen in the CBA in maintenance, than what we had before. Yeah, and then you can optimize, of course, but mounting more is always prone to more failure than mounting something less. Yeah, that's very clear. Yeah, now growth rates, I think this goes to, maybe Michelle.
Yeah, exactly. So indeed, as you say, look, ideally what we would have loved to work with is a simulation model. Simulation model that looks at already set investments, like certain investments, that also looks at the evolution of the different markets within each of the European countries and worldwide, looks at transport forecast, evolution of the different transport modes. But this model does not exist in the level of detail that we want to. And the model that does exist, so the one that is used by the OECD for the ITF transport forecast, in our view, also has some flaws, also has some limitations, and it predicted even like a tripling of rail freight by 2050. So in that sense, we prefer to be even a bit less ambitious rather than using a transport forecast model. Fall back on this EU goal of doubling rail freight. As said, like on an annual basis is 2.3%. When you assume that intermodal transport for the last 10 years has been growing by 6 to 7%, this 2.3% is not too ambitious. At the same time, we consider that for single wagon load and block, it is a more challenging market. Having said that, evidently, we need also to work with the sensitivity analysis and to see what is the outcome of the CBA if we would assume a lower growth, like close to zero growth, and we can even look into what would happen if we would assume like a OECD kind of forecast with tripling of the growth, and all these risks regarding to growth forecast need to be considered also in the financing schemes.
Yeah, but we did a sensitivity analysis, didn't we?
Yes,
Yeah,
on the costs, and
No, but
also
on
we looked at the
traffic,
growth.
No. Also
already
on the
tested
traffic.
that.
Also on the traffic. Yeah.
Yeah.
Not a big, not a huge, also not a huge change. Well, not a change in the conclusion. But okay, I know that everybody is suspicious about this traffic growth. We receive a lot of comments on that. But just to be clear with everybody in the industry, there are also some climate change objective at EU level, and doubling rail freight is not so ambitious compared to the objective of carbon neutrality at EU level. So we have also to keep that in mind. Huh?
And you also have to take it in mind like a general growth of the European economy over that time. So let's say doubling on paper, it sounds a lot, but over a 30-year period of time, actually 35-year period of time, if you look into the details, it is not as ambitious as, for instance, let's say like 35% of modal share. Like that is not being said.
But I think, general remark here to all of you in the audience, the questions that you are asking here are of such a high competence and preciseness. Congratulations. Maybe you would like to join the team here, because that would be very helpful, because you have also detected a key issue here that assumes a lot of other investments in line capacity. This was a crucial point that we always had discussed. And to be absolutely frank and clear, this scenario assumes a large part of realization of the TEN-T infrastructure investments. Yeah, that means we need to have some more bridges and lines. It will not only come out of DAC alone. Yeah, but if we assume that the TEN-T investments will not be done, I think then everything in Europe will have a different view and will have a different situation in transport. Yeah, we'll have to face that.
So we have another 8 minutes left. What I would suggest is we throw in one technical question, which is of importance when it comes to safety, obviously. And then
Please.
I would go to Lieber Lochmann's comment slash question and probably close with the question you see here on top, because I think the modal shift is one of the most important things. And yeah. So
Okie doke. Okie doke. Okie doke. And also here, this question is incredibly competent. I like that, you know, crash perspective. We are working on that, and they have just had the meetings with the RID. And we can assume at the moment that the crash consumption, so the energy consumption within the draw buff gear, that means the central, will be enough and sufficient for the crash worthiness compared to the side buffers. What we don't know yet is how the situation looks at the locus, because there we have impact in the middle and so on. We will see. Okay. Now, Peter, you wanted to go on with which part of the questions with Libor?
Yeah, Lieber Lochmann. It's more or less comments, but as knowing
CBA,
him.
yeah, CBA on the company level is a must, exactly. That means this is the way we present it. We want to go forward. Co-financing on member state level is an illusion. Libo, we like your repetitions because they are true. And this maybe leads then exactly to his last comment. Let us promote this deployment manager and lobby hard for this on all levels, because the idea to fund in the end this development is to find the one single source of funding for that and also for administrating that. I personally also think it could result in a certain, I would not say mess, but complication, if that would be all done in the end by different member states. The one has this level of funding, the other one has this level of funding. The one member state has this level of payback of the benefits via track access charges. The other one has maybe a direct funding and so on. I think this would rather complicate the thing very much. So something in a centralized Libor, I think we don't have to discuss that. We are fully aligned on that, but also for the others here for confirmation, we think that is the best way to go forward. Yeah.
Okay, maybe also just one comment linked to Libor comment on the CBA at company level. For information, the tool has already been used by one stakeholder to do this exercise, and by deleting all the value at national level, but for one country, and replacing the value of a given country by its own value. And it's working. And also, an additional part, we are also currently working on splitting the results of the CBA per market segment: block train, intermodal, and the single wagon load.
Okay.
Yeah, and this brings us to a closing question, I guess, which has partly been answered already by Jens, but just referring back probably to this topic of, I'd say, shift.
Yeah, this is a shift is the one, but I mean, the related question here is if then, and I think, Nicola, we have not analyzed that. That means if we transport less on road, we have less maintenance on roads because we destroy less bridges and less sidings and motorways, and we have more maintenance on rail because we now transport more. Has that been respected?
We do consider some modal shift at this stage, and the benefit of the modal shift. There is a discussion on the allocation of this benefit between shippers, so the final client, and the railway system. So that's one of the big issue. And in the benefits, this modal shift is leading to a decrease in externalities. This is a very important part. So less external costs, less greenhouse gas emissions. Indeed, we know that there should also be a potential decrease in maintenance costs of road, which has not been considered yet in the assessment. And also, there should be an increase of, but it's more of a transfer, because there should be an increase of maintenance costs of rail, but also an increase in track access charges revenues for infrastructure manager. And this is already considered, but this is already considered in the cost of the railway undertaking. So it's a kind of a transfer game within the railway system, which is not completely modeled at this stage, as it has no impact on the overall result of the CBA. And road maintenance cost, we knew it. We didn't have the time to do it in the release of the CBA. Okay, it should increase slightly the result of the CBA, but it's not going to change significantly the overall result and the conclusion.
And we need also to be precise. It is not related to DAC. It is related to an overall growth, you know, and the maintenance of tracks and less on the road has nothing to do with the DAC itself. It has just to do with the transfer, with the shift.
Just for the model shift part.
For the model shift, it is, yeah, exactly.
For the model shift part, yeah, because it's induced by the benefits of the DAC.
Exactly.
Okay. My God, so many good questions. Thanks very much for your huge participation. Peter, are we done with the questions in Slido and the chat
Yes,
and so on?
this was the last question. I guess a very good sort of also sum up question.
Oh, cool.
Bringing us back to
2 minutes left and we are already over. This is great. That means we can only repeat from the program side of view, and especially with so many good contributors here. We need people still working in the WP5. We need companies who are willing to make company exercises with us, confidential benefit cost analysis on company level, anonymous, of course, and to see if we take away all these societal benefits, what remains then for the individual companies. We can also not hide that some companies say they would even have absolutely no benefits. This is also already in the world, but this is normal in such an exercise. And what I personally like is that the discussion is open, and each time we knock on it, we definitely don't lose the positive end result, because we make sensitivity analysis and so on. We maybe have some restrictions, but overall we are in a world which is completely different from the benefit side than, for example, ERTMS. Yeah, but still we have to accept and even to praise. And so if some of you would apply for and would send us an email to say, yes, my company would like to have exactly this business case approach together with you, then we would be happy. If you would have any further questions, I think you also can always ask us. And anything else to say? What are the next steps? I think by next summer, Easter, maybe something we can come up with a renewed CBA. Yeah, when we have.
Exactly. Yeah, exactly. So the next update with using the CBA consultation feedback will be in January. In the same time, we're also working on the case studies, as Jens was saying. Like, if you want to participate or want to provide information, please let us know. We can all be emailed. I think you also will have our contact address. Contact details will be shared with you also after this meeting, if you don't already have them. And besides that, I also want to thank you for the very good questions and for participating. It's much appreciated.
Also more fun for the presenters if there's a reaction. Yeah. In this sense, Peter, Ivana, maybe Ivana, you can turn on your camera again. Thanks so much for organizing that. It has to be, I think it has been fruitful. Yeah. And helpful. So we should do that again. Maybe we should even do this kind of webinars, I don't know, 2 times a year or something, with the updates. And because the community is interested, and that's a good sign. Can we wish all of you a nice working day and then a good weekend and then soon a good Christmas break? But for us, for the moment, we are happy. Hope you are happy too. Thanks so much. And we're looking forward many applications for the business cases. Thanks, team. Ciao.
Bye all.
Thank you. Bye-bye.
Thank you. Bye-bye.
Bye-bye. Bye-bye.
Bye-bye.
You. Bye-bye.